Good morning or good afternoon, everyone. My name is Olga Kakshagina, and I'm an assistant professor and a vice chancellor research fellow at RMIT University in Melbourne. And I'm also a co-lead of the special interest group at ISPIM entitled Breakthrough Methods and Skills. And our goal is somehow to highlight different techniques and methods that practitioners and academics can use in the fields related, obviously, to innovation, technology, entrepreneurship, etc. And as part of the special interest group, we started a new initiative a few months ago. It's called ESPN Methods in Focus. And the idea of this initiative is to pick different research papers that exist out there in the world, published in very good journals, where we actually see how different methods are applied in an interesting way and can be used both for researchers and practitioners. And so here today we are hosting an innovation methods in focus on data-driven design ideation with Professor Jianqi Luo. And maybe just to introduce quickly the topic. So what is this ideation and why is it interesting to look into data-driven techniques? So traditionally, companies need to hire, as you know, experts to find relevant knowledge, analyze patterns to support their overall creativity and ideation. And we also know, and many of you are experts of that design thinking, user studies, market research may also reveal some interesting and novel ideas for ideation, and perhaps even help us identify different opportunities. But those methods can be somehow slow and resource consuming. And so what we are wondering is, what are the alternatives? What can we use for ideation? And that's why today we are hosting Professor Jianqi Luo from Singapore University of Technology and Design, who is managing a data-driven innovation lab that spans across design and AI, technology management, innovation, complex networks and systems. And he's also a director of technology entrepreneurship program at SUTD. And he did his PhD with MIT several years ago, a while ago. I don't remember how many years. And yet then Jianqi and his team somehow explored how data-driven design techniques can be used to provide a stimuli to design ideation. I developed this data-driven conceptual design method that we are going to discuss together today. So first of all, congrats on your paper, which is available, and we are going to share the links with you. And perhaps before we jump into the method itself and talk a bit more about the paper, can you please tell us a little bit more about perhaps yourself and also the design, the data-driven innovation lab that you're managing?
Okay, thank you, Olga, for having me. And also thank you for this wonderful introduction. And so I don't have to say much. It's my great pleasure to be here and join you guys, the innovator community of ISPIM. My name is Jianqi. I'm currently an associate professor at the SUTD, Singapore University of Technology and Design. At SUTD, I founded and run the Data-Driven Innovation Lab. The lab has a very, very simple mission, that is to develop data science and AI-based methods and tools or expert systems, which can help us better address the uncertainty in the innovation process and make the innovators, designers more informed and more inspired when they make decisions about innovation. And so, by nature, data-driven innovation is interdisciplinary. I was very lucky to be able to bring together researchers from different disciplines, different cultures, to do this kind of a research about data-driven innovation. I look forward to the sharing today on GPS is just one of the examples.
Thanks. Thank you so much. And maybe, as we mentioned before, so the goal of the discussion will be to uncover these methods for both researchers and practitioners. So can you please outline what is this knowledge-based expert system and how it works in practice?
Okay. So actually, GPS is, which is highlighted in the paper, is a cloud-based, data-driven, computational, and visual design support system. So I prepared a very short video clip, like a video demo of how the visualization system work. Maybe I should pop up the video and show it when I talk about it. It's a very short video. Can you see the video?
Yes.
Okay, so traditionally, the ideation of design and innovation opportunities and exploring new innovation and opportunity or directions relied a lot on human expertise, intuition, brainstorming, or other social processes. And it's very uncertain and very serendipitous and based on luck. And in order to make the innovators more inspired and more informed when they search for new ideas or new innovation opportunities, we developed this system and GPS with a lot of inspiration from Google Maps. When we need directions and to travel in a physical space, when we need to decide what food to eat, which restaurant to go to, in a physical space, we use Google Maps, right? Google Maps allows us to position ourselves, explore neighborhoods for food, for fun, for hospital, for needs, human needs, or directions to travel from where we are to far fields in the physical space. Actually, GPS does the same, but just in the technology space, and GPS integrates. It's actually based upon an empirical map of all the technology domains based upon the International Pattern Classification System to provide a technology geography. And those domains are positioned according to the knowledge distance based upon our quantification based upon pattern data. And the map is integrated with a number of functions, analytic functions to precision technologies, companies, and innovators, firms, and explore inspirational stimuli, explore people, companies, technologies in near or far fields, according to knowledge distance, near or far fields to where you are in the technology space in terms of your capability, your interest, your design problem. So you can potentially retrieve inspirational stimuli from far or close fields for design synthesis, design knowledges for innovation. And so as you can see visually, the tool actually makes the traditional intuitive or social process to search for innovative ideas and opportunities more data-driven and more visually inspired and also rapid. That's it.
Thank you for the summary. Maybe we can stop sharing. And to some extent, I understand. So you created technology maps based on the ideas of different topics or concepts that you have in mind, and then try to identify some stimuli. And maybe can you guide us a little bit more on what type of design heuristics you actually use to create these novel ideas within the field, or perhaps even further from the initial fields of technology search?
So, and actually our inspiration for creating this was analogical thinking. So as I elaborated briefly just now, we got a lot of inspiration from Google Maps. When we get lost, when we travel in a new city, right? We don't know, we have 5 hours before my flight back to my country. I want to kill time. I want to find a Starbucks. Where is it, right? Or I have no specific targets. I just want to explore the neighborhoods and decide what to do to make my 5 hours more meaningful, right? And what do? We use Google Maps, right? Because Google Maps actually provide the information about opportunities for you to visit in the neighborhood, far or close. Then it also provides the information about distance. That distance information is very important to guide and inform your decision, right? GPS does the same. It not just tells you how inform you about opportunities, like concepts, technologies, collaborators in far fields and near fields. Most importantly, it tells you how far and how close those opportunities are. So you will be able to make more informed decisions. And we actually did a lot of design science research and to validate the knowledge distance information as we quantify it actually can provide meaningful guidance about innovators' behaviors and performances. For example, we found out innovators, based upon our analysis of millions of users, actually tend to stay around in the neighborhood domains for innovation. But when they go into far fields for innovation, and once they succeed, but the chance is very small, once they succeed, it's more likely that they can get breakthroughs. And sometimes we don't go into far fields or new fields. We just draw inspiration from other fields for leveraging solutions from other fields for solving problems in our own fields, right? We stay here we draw inspiration from other fields. And our human experiments also found that innovators, designers actually most of the time find the stimuli from near fields useful. They can most of the time see the relevance between their design problem, design interest, and the near field stimuli, according to our knowledge distance quantification. But the most novel inspiration actually comes from the far fields. The novel concept generated actually draw inspiration from far fields. So that provides this radical foundation for us to build this map, a useful map, which can provide meaningful knowledge distance information to guide innovators to search for design opportunities across near or far fields.
Yeah, this is a very interesting, and indeed we see this difference between do we innovate by using the existing knowledge, or do we actually seek for knowledge which is further away in order to inspire and perhaps have some breakthrough ideas and concepts. And you mentioned that you validated this approach with using design science with different groups and teams, and I was just wondering, are there any surprises or interesting cases that you can share with us where, for example, you yourself were surprised by using this tool?
Yeah. So actually, we had a lot of students at SUDD using GPS for their design projects, and also companies trying it, and the university researchers for different applications that we didn't think of. When we started building this, my motivation was actually to help the students and also help the companies who came to my office for ideas about new designs, new innovation opportunities, right? And they're always thinking about that. They have this product, that product, they want to see the new product in the next 5 years for companies. For students, when they do design project, they need to decide what to design, right? With the technology, the knowledge they learn. So we brainstorm all the time. And I was very happy because, I'm an introvert most of the time, and my personality is very introverted. I like to help people, but my mental energy is very limited. I cannot brainstorm so much with so many people, right? So many students and hundreds of design projects, design teams I've supervised at SUDD. It's exciting, but also tiring. So that's why we created this, GPS as a tool to support, most of the time supporting students, but sometimes also companies. I've seen quite interesting use cases of GPS by our students, most interestingly from students. For example, one student team was preparing for ideas to participate in novel AI, innovative AI application competition 2 years ago. And they were brainstorming, and 5 of them brainstorming, generating ideas for participating in the innovation competition. And they were stuck, like brainstorming for a way. They were stuck only generating 5 ideas. They were not very happy about the novelty of their ideas. So they came to me, right, for me to give them novel ideas. And I said, oh, I'm not smarter than you guys, but I have a computer tool you can use to generate ideas. So I shared the tool with the student, and they spent about 30 minutes just browsing the map, exploring ideas across different fields with a very distance from neural networks, because their design requirement is to use neural networks, but they are supposed to generate novel applications of neural networks, right? And in 30 minutes, the group of 5 students generate like 60 ideas. Then they rank the ideas, select one to produce in the competition. They won the first place. And the first place, that idea is AI empowered digital calligraphy. And the idea was inspired by something they see in this domain on the map called writing articles. And they thought, wow, actually AI and neural network can be used to empower people when they write. Right? When we write, our calligraphy look ugly, but AI can actually, neural network can automatically adjust our calligraphy no matter how ugly I write. So the fonts will become beautiful with AI augmentation, right? So that was the idea they generated with inspiration from the map. And they got the first place in the competition. And the students they won like 10,000 Singapore dollars. They were very happy about that. That's just one example how GPS can help students for their design projects. I was also surprised by some use cases, applications by MBA students and business school professors. So one time I was visiting Tsinghua University in Beijing, the business school, and my friend is a business school professor. He said, "Can you help my student brainstorm with him about his master's thesis an MBA master thesis about technology innovation in the semiconductor industry. So I talked to the student, and he eventually used InnoGPS to analyze the competitive landscapes of companies in the semiconductor industries and how technologies of different companies evolve in terms of the knowledge distance between different companies and the knowledge distance between technologies, new and old ones, and technology portfolios of different companies. I was very excited to see that a student, MBA student, actually used InnoGPS for business intelligence analysis. And I also discovered a professor from University of Waterloo actually used our InnoGPS for a paper, the paper for joint conference, and analyzing the knowledge distance between startups and the prior employers of the entrepreneurs who started the company, right? So that was very exciting. Those are surprising applications of InnoGPS. We didn't envision when we started out by just with the motivation to design it as a design ideation tool.
This is super interesting, and somehow you made a perfect transition to my next question. You did mention that it was initially designed for ideators, designers in the companies, but you as well show that, yes, of course, it can be used for education, but also maybe for research. Can you elaborate a little bit more? I know that we have a lot of academics here in the audience. How researchers perhaps can use your tool, and what will be what are potential applications in addition to what you've mentioned already?
Yeah, I think there's a great potential for management, economics, and business scholars interested in innovation, technology, innovation, and to utilize to do some analysis about knowledge distance and the positions of different companies, right? Capabilities of different companies, their patent portfolios, or generally speaking, technology portfolio, as long as knowledge distance is an important variable in your analysis, in your decision-making for business, innovation intelligence, or competitive intelligence, the InnoGPS can be useful. I'm also very curious how, what kind of application, what kind of analysis can be developed with the problems from the business school or from the management scholars, researchers, and other than engineers, because most of the time we actually just interact with engineers, designers, the innovators who want to design a novel robot, okay, fixing a problem, like water saving in the tunnels, right? Most of the time that's the group of people we interact. I'm very curious about how the academic researchers studying innovation and management of technologies can make use of InnoGPS. I just mentioned two examples, right? MBA students use it for competitive intelligence. This school professor use it for entrepreneurship research, right? They look at the knowledge distance as a key variable. So I'm very much looking forward to seeing more applications, more novel applications of InnoGPS in a greater community. Yeah.
Yeah, this is great. And if I, for instance, to use it tomorrow, what would be the way for me to access it? Do I just have to create a login, or is it?
Yeah, just email me, send me an email and tell me that you want an account. Then I will ask my PhD student to create an account. So in a few hours, you can access it.
So anyone in the audience, if you are interested, you might consider doing the same. And by the way, before I'm asking my next question, if you do have any questions, please put them in the chat, or perhaps even raise your hand so we can take them directly. And yeah, maybe the next question, in a way, going a little bit further towards the industry, you did obviously patent landscaping, maps, it's something that already exists and many industries are using. So perhaps you can elaborate a little bit more. What is the novelty of this kind of tool for, I don't know, any high-tech company which is R&D driven, given that they might use solutions like Questel or others who actually allow them to create cartography of patents?
Yeah, so traditionally, the early phase of designing or early phase of innovation, like conceptual phase, is very human-driven and relying on experts, very serendipitous. You know, I'm a professor. I've been approached by companies all the time. They just come into my office for ideas about what they can design. And they do this for not just with me, but with so many professors, so many random experts they found from internet, right? Expert panels and individual consultation or brainstorming session crowdsourcing. In any case, we're trying to tap on individual human brains intelligence or knowledge for inspiration, right? And just imagine how difficult it is to reach out to people, to schedule a meeting. And everybody is limited in our knowledge, in our bandwidth, right? And the process of it really depends on who you run into and the emotion and mental energy of the person when you meet, right? It's very serendipitous. I strongly believe a computer with the cumulative knowledge stored in data about all the engineers, all the innovators in human history over time, and stored on computers can be the collective brain that everybody can easily access and seek inspiration from. And you don't have to reach out to professors or experts individually. You can just talk to this virtual expert with a lot of knowledge, cumulative knowledge of millions of innovators in human history in one place, right? Just talk to that one. Look at that computer as a virtual, highly knowledgeable expert with knowledge from all possible technology domains. Just talk to the person, interact with that virtual expert. You'll get a lot of more inspiration. I'm very confident about that. Even though InnoGPS is a very preliminary effort, I believe our team and other teams, other research labs and companies are also doing similar things. And more tools like InnoGPS, the better ones will be created down the road that companies can use as virtual innovation experts and to put them as part of the team of brainstorming or expert panel, but just including the virtual expert, right, to augment our creative process, and so the outcome will be more creative. So I'm a strong believer of creative artificial intelligence and data-driven expert systems for innovation. And my belief is largely based upon my observation of the computer-aided design tools like AutoCAD, SolidWorks. Those tools didn't exist, by the way. They didn't exist, like MATLAB, right? They were conceived like 50 years ago by researchers. And now it's on the computers of most of us, right? We're students. When I was in university more than 20 years ago, I was sketching design drawings on the table. Now our students don't do that. They go straight to computers, right, to design, to model their ideas. I strongly believe for ideation, concept generation, the early phase of a design, and 20 years down the road, you will see more and more people go to computers instead of professors for ideas. Okay, so that's my prediction of the future ways of innovating with computers and data.
Yeah, that's great. And to some extent, I'll go to the question in the chat a bit later. But before that, I mean, the way I understand, so the InnoGPS today is designed using Python data. And and to some extent, it might be limited to technological innovations. Do you think that it can be used for non-technical or technological inventions or stimuli as well? Or yeah.
We have we have already trained the neural network classifiers that can classify any natural language representation, description of ideas or artifacts into this vector space. If you look at the map, actually it's a vector space, right? There are different dimensions, right? It's a classification system, and we train neural network classifiers. So even while we're talking about it, our verbal conversation can be classified into certain spots in a map according to its essence and using our neural networks. So any data, any modality of data about technologies and innovation can be parked into different spots of the InnoGPS classification system. Yeah.
Which makes us closer to what you mentioned earlier on creative artificial intelligence, like basically using any type of data, structured and non-structured, in order to create these stimuli. Very interesting. And we have a question from Stefan on basically, can you perhaps elaborate a little bit more through a simple example how this method works exactly? Perhaps you can use an example in the paper as well. So the paper itself has 2 case studies, and they're actually quite interesting.
Sure. So you want me to pop out the paper?
Not necessarily. If you can maybe imagine an example and just provide us an example of analogy or combination that the tool can perhaps lead us to. Okay.
So in the paper, we actually elaborated the 2 examples. In one example, the innovators have a successful product, a rolling toy, but there's no design problem. There's no problem. You just want to innovate, generating more product concepts for the next 5 years, right? So with GPS, you can just key in rolling toy. That's the design domain of the initial product. Then you can see the red bubbles highlighting the current domains where spherical rolling toy has been designed. So those domains actually have some part are relevant to what you have done. So in order to innovate, we go beyond those highlighted positions of existing rolling toy designs. We go into the white space, right? The domains, the gray domains where we haven't found any rolling toy related designs. Then we go into those domains to explore the design concepts in those domains. The design concepts have already been processed through our natural language processing work. They're already presented in different domains, different bubbles. Right? Just like you want to explore pizza, right? In Melbourne, for example, right? You just key in pizza. Then you find pizza shows up in different spots, and or sometimes you get tired of a pizza, you want to eat something else, right? You avoid pizza, you go into white space. Just look at the map to decide how close you want to go. So with knowing where rolling toy designs have been created in certain domains, you go into the white space where there are not any rolling toy being found, and you go in those places and you explore the design concepts over there, combine them with this concept of rolling toy, right? Then you can generate a lot of ideas. For example, if you, in the paper, we presented some cases, like if you go into a domain called the lighting, right, you will see design concept like LED, right? Actually, we can put the LEDs in the rolling toy to make it a moving light, right? So the ball rolls around in the park at home with LED, providing mobile lights. Fantastic. Actually, that was one design concept that students generated using GPS. Maybe I can show you this. In my video, the video I showed.
We can show maybe the video again, but maybe to recap, what I find where it is interesting is, for instance, you take any concept that you are looking to create additional ideas to or alternatives, and you basically, based on that concept, like let's imagine, for example, biomimetism, something that we use to actually see what are the inventions in the further fields that can actually create some stimuli for your ideas. And for instance, here for rolling toy, you can see where ideas can come from other fields or other domains in particular. But yeah, John,
can you see the demo now again?
Yes.
Okay, so the workflow is like this with precision rolling toy. That's our practicing domain. That's where our successful products were. Then we look at those bubbles have rolling toy design already, but the green ones are white space. Right? So what we can do is go into the near or far. So GPS actually tells you how far your the domain, different domains, how far are they from rolling toy. And you can jump into certain specific domain, like checking device, for example, which is a white space domain. You just explore the concept there and combine them. You can combine display and gaming with a rolling toy. Now you have a moving gaming device. You can have a camera, like monitor concept is from checking device. Okay, let's combine monitoring function with a rolling toy, make it a surveillance card, a sort of moving surveillance robot, right? Authentication, we can put some authentication function like RFID chip inside. Data collection, yes, we can put sensors in the rolling toy, let it move around to collect data in places where people don't want to go in, like a dangerous environment or small, narrow pipes, right? We just send it in with sensors to collect data. And you can randomly browse the map to explore design concept in any domain. Like this is the example I just mentioned, LED from lighting. Let's combine it, right? And combine it, generate mobile lights. Actually, the inspiration and design concepts, inspiration stimuli can come from any color of the total technology space. And at the same time, the system will inform you how far the inspiration is, right? And to your original design problem. So that distance information will inform you about the potential feasibility and the potential novelty of the concepts. Right? If you're drawing a far field inspiration, you might get novelty very high novelty, but feasibility can be very low in terms of prototyping, manufacturing, marketing, right? If you're drawing inspiration from near field, most of the time you see it will work. It's very feasible, but novelty might be limited to yield potential innovation. So there's a trade-off that you have to decide a trade-off determined by knowledge distance. It doesn't matter what decisions you make, depending on your interest, your personality, your risk appetites, and the system provides information and to make your decision more informed. Just like Google Maps, right? If you have 2 hours, you can travel far to get the best food in your province, right? And if you don't have time, you can only travel within 10 minutes for lunch, right? So, but the Google Map will tell you the opportunities, what kind of places you can travel, given your resources and constraints. Right. In this case, if you really want to go into a far field, you're a rolling toy company, but you find that your knowledge about rolling mechanism can be used for agriculture, right? But that's tough. It's a far field, right? As a toy company, how do you enter agriculture industry and get clients and to give you dollars to develop rolling robots for fertilizer distributing a farmland? That's a far field. It requires a lot of learning capability building. And from the map, you know, it's a far learning process, but it's okay. You're informed, right? And you need to be prepared for the time required, for the resources required for traveling from where you are to where you want to go. That's it.
Yeah, so thanks for sharing and re-explaining the concepts. I think everyone appreciated that. So please feel free to put your questions in the chat. And for Sophia, yes, the tool can be shared with you for research purposes. You just need to contact Janchi, and he'll discuss it with you and provide you the access as we discussed earlier.
Yeah, just drop me an email and tell me that you want an account, and we're going to create it. It's free, and you need to pay for your use with your feedback suggestions. I appreciate that.
That's a good one. And I mean, somehow I see in the GPS that you mentioned using patent data, and you mentioned other possibilities of using maybe non-structured data or other kind of classifications that can inform our ideas. So I'm wondering what will be the future of GPS, or what perhaps are you currently doing in that direction to improve the tool, to enhance it, to apply it in different contexts?
Yeah, there's a lot of opportunities. You know, we have been observing a lot of trial uses, users from company, governments, and researchers, students. A lot of them are students. One thing I discovered very interesting, which is a limitation of the current tool, is the efficacy of the tool actually is limited or conditioned by the creative thinking routines of the user. So if the user doesn't have analogical reasoning capability, if the user doesn't have combinational thinking capability or other transformational thinking capability, it's very hard for him or for her to make sense of the inspiration presented in front of the person, right? Just imagine if you're brainstorming with a student and the student doesn't have creative thinking skill, no matter what you tell the student or the person cannot make use of it for innovation. You say, right? You try very hard to inspire, but the person cannot transform the information from you. So it doesn't lead to anything. So I realized the efficacy or usefulness of the tool is actually conditioned by the user's ability of making use of the data, making use of the concept. Let's say we present this concept called LED to a person. The person cannot make use of it, cannot see the relevance between LED and a rolling toy, then it's useless, right? So I realized that's a limitation on the users. But we do see a lot of creative people in the teams. Every team has some creative people who are good at the combination of thinking and logical reasoning. Make sure if we are going to use a tool, make sure we have some people, creative people with creative thinking routines already in the brain, in the team, as part of the team. But moving forward, what I want to do, actually, our team has been working on, is to move away from computer-aided ideation to computer ideation. So GPS provides computer aids, right? Data to inspire you, concepts and terms and visual to inspire you, inform you, but you have to innovate, right? And it relies on your creative thinking skill. And we want to get away from that and to design computer ideation system. So the computer itself can generate ideas, and you don't have to be smart and you don't have to think. What the users should do is to provide the design problem or design requirements. and also evaluate and select ideas generated by the computer and present it to the user in natural language form. We have been designing a system called the InnoBrain, which has a creative artificial intelligence and automatically generate concepts from different from data stored in a computer. So InnoGPS actually provided the basis for the structured knowledge base. And what we did as a top up in the InnoBrain system is the computerized creativity algorithms, transformation algorithms to transform data into new concepts. And that's work in progress. And it's actually working but crappily. So hopefully in a year or two, you will see the InnoBrain system being published. And so that's what we're working on, computer ideation beyond computer-aided ideation.
Very interesting. And I mean, would love to see InnoBrain and even see what will be, let's say, benefits or even some consequences that we need to consider on implementing those in the workplace. Before we go forward, we have a question from Beirut on basically, he would like to know what algorithms does this tool, what type of algorithms you are using to measure technological distance and
That's a fantastic question. Actually, the key variable in the system is the knowledge distance measure, right? So actually, we started out to explore different measures based on patent data. So we look into different information items in the patent documents in different domains. We also look into different info metrics, how we associate documents information across different data sets. So we actually experimented with the choices in terms of co-citation information, co-classification information, co-inventory information in the patent documents, different data items, and also different metrics like cosine similarity, Jagged index, and other normalized metrics. We explored more than 30 metrics. Then we compare that in terms of the predictability of the metric, predictability on the movements of the inventors across different domains. And we identified the optimal one, the best one, the most predictive metric. Then we use that for the current system. And recently we run another experiment using neural embeddings. So we created to create a metric measuring distance between different measures. So that goes beyond the traditional association rule-based measures to relate different categories of documents. So our published work actually expanded more than 30 metrics. We compared and selected the optimal one. But something that we haven't published, we have done is to create a knowledge graph of inventors, companies, patents, classes, in a knowledge graph structure. Then we look at the knowledge graph and just crowd information and train a neural embedding and turn the knowledge graph into a embedding vector space. So all the domains, all the people, all the patterns, all the classes are now vectorized. So we can automatically, in that neural embedding space, we can automatically derive a measure of knowledge distance. However, we found even by doing that complicated neural network analysis, we couldn't derive better metrics. So the traditional association rule, one of the association rule-based measures still remains the best. So we're trying to develop and explore more and better, more predictive and knowledge distance measure, but by far. And so the neural embedding based one is very close to the best one we currently use on the website, but not better. It's very close. So we hope we can develop better ones, and it's endless work, but it's just exciting and interesting and curious. We're very curious whether we can actually derive better knowledge distance measures.
Very interesting, and maybe we can think of providing an advice for, I don't know, PhD students or early career researchers who are looking into data-driven design techniques. For instance, trying to develop one themselves, or maybe using the existing ones. What would you suggest them to, let's say, to focus on to avoid any pitfalls or mistakes that you perhaps had to deal with while developing in GPS?
I think there's a great potential from deep learning in these days, going beyond the traditional machine learning methods or data science methods looking at local statistics. I found deep learning or multi-layer neural networks can be, it's a black box model, but can be very powerful sometimes. for processing large scale unstructured data, make them very structured and organized into vector space. And we're doing a lot of work leveraging deep learning capabilities to rebuild this knowledge base. Right now, you see a map, different bubbles, they have vectors representation in the backend. So that was based on traditional associated roles in traditional data science. And we're revamping the system in the backend by using deep learning in different front, like what you asked just now, how we park unstructured massive data, any kinds, right? Like a voice, a picture, into the knowledge base, right? In a structured manner, how do we classify them into different domains? And deep learning is the approach to use. That's what we use, and to further develop the knowledge-based system for innovation. So I believe deep learning has a lot of potential for us to explore for data-driven design innovation research.
Very interesting. And I might have time for a very final question, but I'm just checking if anyone else wants to, if you have any comments or questions in the audience, please put them in the chat. We'll make sure that we'll answer them, but we are running a little bit out of time. So perhaps, Janchi, are there any closing comments or takeaway for our community of innovation practitioners and researchers on using those type of tools?
Okay, first of all, thank you, Olga and ISPIM, for having me. I enjoy this conversation, your questions and questions from the audience. Those are very fundamental, important questions. I just want to say that, I have a very strong personal belief about the value of data for innovation. Because, when we innovate, innovation is uncertain, right? By nature, by definition, is uncertain. When we innovate, we're trying to create new products, new services, new system, new process. The creative process determines it's going to be uncertain, right? We don't know what to create. It's very uncertain. By nature, if there's no uncertainty, there's no innovation. It's like assembly line workers don't face this kind of uncertainty, right? But the opportunity is that we see a lot of data being generated every day in the design process, in the innovation process, in business, in our life, right? And if we can properly mine those data, and make sense of them, there's great potential for us to make more informed and inspired decisions for innovation, just theoretically speaking. And we can do a better job, we can do more informed, inspired job for innovation. If you're like-minded, if you are like-minded and believe in the power of data for innovation, and please stay in touch. Let's see if we can collaborate in the future.
Yeah, definitely. And it's super interesting because we can actually see how we can co-create between technology and machines and actually ensure and humans, and ensure that we can actually benefit from advantages and perhaps disadvantages of the different methods that are out there. So thank you so much.